So after addition and subtraction of polynomials, we're going to learn how to multiply them. So by the end of this lesson, you should be able to multiply a monomial and a polynomial together. You should be able to multiply two binomials, and then a binomial and a trinomial. And all of this stems from the distributive property. So if you remember when we talked about this in chapter 2, you have something on the outside of parentheses means that it needs to get multiplied by everything inside the parentheses. So we draw these nice little arrows. Let's make this one a little better. To remind ourselves that A and B need to be multiplied together and A and C need to be multiplied together. So I gave you problems like this one down here where I said 6 times x minus 2. We kind of skipped this step, but technically what we were doing is when we drew this arrow, we were saying we got to multiply 6 times x, and then our next arrow, we got to multiply 6 times negative 2. And then you end up simplifying it if you can. So 6 times x, you can't simplify. You just get 6x. But then 6 times a negative 2, you end up with negative 12. And again, if you could, you would go through and you would simplify that, but we can't, so we're done. And same thing with a negative here. You got to watch out for your signs, but you're doing the same thing. Negative 3 times 4x, and then negative 3 times negative 1. You simplify and add or subtract if you can. So now we're just going to do that with polynomials. So I'm going to give you a problem like this, and the steps are exactly the same. You want to do 4b times 5b squared, and then 4b times b, and then last one, 4b times 6. So that 4b gets distributed to all three of those things in parentheses. And then all we have to do is simplify these things. So the reason we learn exponent rules before this stuff is because we need to use our exponent rules. So just like we did before, you take your numbers and you multiply them together. And then this is like b to the first power times b squared, which gives us b cubed. We gotta do the same thing for this one. Multiply our numbers together, so it's just a 4. And then b times b gives us b squared. And then finally, our last one, we just have numbers to multiply together. So 4 times 6 gives us 24, and there's only one b. And then you double check two things. Is it written in standard form? Just because that's the nice pretty way to write it. It goes 3, 2, 1, so yes. And can I simplify anything? And because all of those have different exponents, we can't add or subtract, so we're done. And that's it. Let's try the next one together. So same thing, we're going to take this negative 7h and multiply it one by each one of these things. Eventually, you'll be able to skip this step that I'm doing right now, but right now, since it's new, it's really important. So negative 7h times negative 8h, and then the last one, negative 7h times negative 1. And then simplify where you can. So negative 7h times 3h squared. You take your numbers, you multiply them together. I have 1h and 2 more, so I end up with 3. Now the green part, negative 7 times negative 8 is a positive 56, and h times h is h squared. And then finally, negative 7 times negative 1 is positive 7, and we just have 1h. So again, I'm checking it's in standard form, and I can't combine anything, so I'm done. I'm leaving this one for you. So it gets a little harder, but basically it means exactly the same thing. Back here, we only had one thing that had to be distributed to everything in parentheses. When we write something like this, we have to distribute twice. What this is saying is that this 6h needs to be multiplied by everything here, but then also the negative 7 needs to be multiplied by everything here. So we like to call this double distribution, because we're just distributing twice. But all we have to do is write this out. So the first one we do 6h times 2h, and then we did 6h times 3, and then we took the negative 7 and multiplied that by 2h, and then negative 7 times 3. And just like before, you simplify. So 6 times 2 is 12. H times h is h squared. 6h times 3 is just 18h. And then for the green part, we have 7 times 2h, which is negative 14h, and negative 7 times 3, which is negative 21. So before I box it up, I want to check two things. Is it simplified, and is it written in standard form? In this case, this is not simplified. These guys right here both have an h, so that means I can combine them. So I'm not going to do anything with the 12h squared, so that just stays there. But if I have 18 horses and I subtract 14, I end up with 4 h's, and then minus 21 can't be combined with anything. So I'm done. So let's try another one. Double distribution. You're just distributing twice. So for this first one, 5m needs to get multiplied by 8m. And 5m also needs to get multiplied by negative 1. And then 2 needs to have its turn. So 2 needs to be multiplied by 8m. And 2 also needs to get multiplied by negative 1. So if we combine our things here, we get 40m squared minus 5m. And then we end up with 18m's minus 2. And just like the last one, we have some stuff that can be simplified. So we got to combine those. 40m squared doesn't do anything, but negative 5m plus 16 will give us 11m minus 2. So now it's simplified, it's in standard form, I can box it up. Chances are you guys have heard of multiplying like this before, and some people like to call it FOIL. FOIL just means multiply your first numbers together. So like I did here, 5m gets multiplied by 8. There's my first ones. O stands for outer. So like I did 5m times negative 1, they're the outside ones. And then the I stands for inner. So I did 2 and 8m, those are the inside ones. And then L stands for lasts. So you do 2 and 1. Double distribution is easier for me, so that's what I tend to call it all the time. But if you ever hear the word FOIL, that's what it's talking about, is just double distribution. Just like before, I'm going to save that one for you. All right, so they get a little harder, but the game is still distribution. This x needs to be distributed to everything inside these second parentheses. So we'll do it step by step. X needs to be multiplied by x squared. Then x needs to be multiplied by negative 4x. And then x needs to be multiplied by 1. So now the x has had a turn. Plus 9 gets a turn. So he needs to be multiplied by everyone as well. 9 times negative 4x. It's positive 9, so we got to add that. Negative 4x. And then 9 times 1. So combine our stuff. This part should be old news. So x times x squared, remember there's a 1 there, that gives us x cubed. X times negative 4x gives us negative 4x squared. And x times 1, that's an easy one. We just get x. And then we get 9x squared minus 36x plus 9. So this time we got a lot of things that we can combine. So look for your like terms, because remember when we did addition and subtraction, that's all you could combine. So x cubed doesn't have any friends. He's just going to stay there. Negative 4x squared can be combined with 9x squared to give us 5 of them. And then we have positive x minus 36x, so that gives us negative 35x's. And then just like the x cubed, 9 is all alone, so we just add him on the end. It's all written in standard form, so we're done. I'm going to leave this one for you. So then you're going to get some special cases. And these are no different, except they start off looking a little different. these two are called perfect squares. And it's because when we see this, remember anything squared, like x squared, means that you have x times x. 3 squared means you have 3 times 3. So this t plus 6 all squared really means that I have t plus 6 times t plus 6. Mathematicians are really lazy. We want to skip writing a step like this if we can. So it's easier and quicker to write it like this. But when you see that, you need to think this. And then we can go back to double distribution. So all we got to do here is take t and multiply by t. So t times t, and then t times 6. And then 6 times t, and then 6 times 6. Simplify what we have. We get t squared here, plus 6t, plus another 6t, plus 36. Combine our like terms there right in the middle, so we get t squared plus 12t plus 36. So let's try another one. Let's try C. So when you see this, remember, think this, that you have 2 of them. And then double distribute. So 7m times 7m, 7m times negative 2p, and then, let's get a different color, negative 2p times 7m, and then negative 2p times negative 2p. So we combine what we can. Multiply our numbers together, we get 49. M times m is m squared. If we do this, we end up with negative 14 mp. We actually get the same thing here. Negative 2 times 7 is negative 14 mp. And those two multiplied together gives us a positive 4p squared. And just like before, combine those guys. 49m squared minus 28mp plus 4p squared. And these things are called special cases because you should be noticing a pattern here. Anytime you have a square like this, the first number is this number squared, and your last number is that number squared. Now this number in between comes from multiplying these guys together, t times 6, twice, because remember we had 2 of them up here. Same thing happened over here. My first number is this guy, 7m squared squared, right there. And then if you do negative 2p squared, you get that. And if you do 7m times negative 2p twice, you end up with this guy right here. So if we skip the next slide and go to this one, that's this guy. Now these rules you can memorize if you like memorizing rules, but you should definitely notice the pattern. If you have the same thing squared, your first term and your last term are just those 2 things squared, and your stuff in the middle is twice those numbers multiplied together. The same thing works for negative, it's just you end up with a negative here. I'm going to leave this one for you to do. So then here's the other special case that we got to talk about, and then we're done. These ones look a little different when we start. If you notice, they're exactly the same besides the sign. So let's see what's so special about these when we multiply them together. So double distribute, just like normal, d times d, and then d times negative 11. And then we'll take 11, multiply it by d, and then 11 times negative 11. So d times d gives us d squared. This gives us negative 11d plus 11d minus 121. The special thing that happens here is when we combine our like terms, they disappear. and we get this. And if we do one more, the pattern you're going to notice is when you have opposites like this, your middle terms will always cross off. And you'll be left with this number squared minus this number squared every single time. So let's try it. We should end up with this number squared minus this number squared. So let's prove it to ourselves. Take this, multiply it by that. So 9b cubed times 9b cubed, and then 9b cubed times negative w to the fourth. And then we'll do w to the fourth times 9b cubed, and then w to the fourth times negative w to the fourth. Hopefully you're catching on and know what's going on here. 9 times 9 gives us 81. B cubed times v cubed gives us v to the 6th. If we multiply these together and these together, we can quickly see that we end up with stuff that crosses off. So again, our middle terms here go away, and we're left with 81v squared minus, that's v to the 6th, minus w to the 8th power, which is just what we predicted. If you take 9v cubed and square it, you get 81v to the 6th. And if you take w to the 4th and square it, you get w to the 8th. So again, here's a rule for that. You can memorize the rule, or you can just double distribute. But notice the pattern. When you have the same thing with opposite signs, your middle terms should cross off. So there's one more for you to do. So you should be able to multiply a monomial and a polynomial, two binomials, even the special cases, and then a binomial and a trinomial. So finish the 4 or 5 problems I left for you, and if you have questions, make sure you write them down and we can go over them in class together. Enjoy your night.